Yeah, student, today I'm going to discuss a very important topic of class 12th, that is Gauss law of electrostatics. Gauss law of electrostatics. As from the topic, we can easily understand that this topic is from the first chapter of class 12th, that is electrostatics. Okay, what the Gauss law of electrostatics tells? The law says that the total flux through a closed surface through a closed surface is 1 by epsilon naught times 1 by epsilon naught times the net charge enclosed by the surface enclosed by the surface. This is basically the statement of the Gauss law of electrostatics. The statement saying that total flux through a closed surface. If you are saying about the closed surface, it means the surface in 3D. Closed surface will be always in 3 dimension. That means closed surface like a sphere, like hemisphere, like cube, cuboid, cylinder. All these are have the closed surface. Okay, but if you will take the circle, rectangle, a square, this will be not the closed surface. Okay, so total flux through a closed surface is 1 by epsilon naught times the net charge enclosed by the surface. We can understand by this topic, by this statement like that, if this we have a sphere, let's say this is a sphere and a charge q is inside this sphere at any point inside this sphere, then the total flux through this sphere, that is phi, will be equal to 1 by epsilon naught times the net charge enclosed by the surface. That means phi is equal to, we can say, phi is equal to q by epsilon naught, where q is the net charge inside the surface, or we can say here inside the sphere. This is the basic statement of Gauss law. Gauss law, we can say, this is nothing but it is only the jugaad of the Coulomb's law. If you want to calculate the electric field of some bodies which are not regular, just like if you want to calculate the electric field of the sphere, if you want to calculate the electric field due to a line charge or sheet, for this body we can calculate the electric field easily by using the Gauss law. But the body which have the not regular surface, or which have the not regular charge, then we cannot use this formula or this statement of the Gauss law. Okay, now let's say there is a question that if we have a cube if we have a cube if we have a cube and there are two charges are placed inside the cube, there are, let's say, two charges inside the cube. Here is, let's say, 5 coulomb and this charge is inside the cube, and there is another charge, let's say minus 3 coulomb, and question asking what is the flux through this cube. That means total flux is what? So total flux will be what? Total flux through this cube will be q net by epsilon naught. We can say q net will be what? So q net will be 5 minus 3, because there are two charges, 5 coulomb and minus 3 coulomb. So total charge will be 5 minus 3 upon epsilon naught, or we can say this will be 2 by epsilon naught. If question will ask about the flux through one surface, flux through one surface, then what we will do? Here the cube have 6 surfaces, as we can see easily. Okay, there are total 6 surfaces in this cube, and the total flux through these 6 surfaces is 2 by epsilon naught. So we can say flux through one surface, that can be represented as 5s, will be equal to total flux phi upon 6. and total flux phi is what? The total flux phi is 2 upon epsilon naught divided by 6, and so this will be 1 by 3 epsilon naught. That means total flux through the one surface of this cube will be 1 by 3 epsilon naught. Okay, and this question is also asking in another way like that. Okay, if we have a square, let's say if we have a square, and let's say side of this square is 10 centimeter, here is also 10 centimeter, 10 centimeter and 10 centimeter, and a charge is just above this square from the center, just above this square from the center, and at a distance of 5 centimeter there is a charge q is placed. And then question asking that ki what will be the total flux through this square. Question asking that flux through the square. Okay, so now how we will easily calculate? So we will draw a Gaussian surface, that will be the basically imaginary surface that will enclose this surface inside it. So how we can draw the Gaussian surface? So we can draw the Gaussian surface like that. This is a cube, as the given surface is a square, so we can draw the Gaussian surface like a cube, and this is, let's say, the Gaussian surface, and the given square is, let's say, this. Let's say this is the given square. This is the given square through which we want to calculate the flux. And above this square, the side of this square is how much? 10 centimeter according to the question. And above this square there is a charge q is placed at a height of 5 centimeters. So we can say this charge q is totally inside this cube, and the flux through this cube will be what? Flux through this cube phi will be what? Q by epsilon naught. But we want to calculate the flux through the one square, through the one surface, because here is only one square is given, and we want to calculate the flux through this square, and we have just shifted this square here. So if you want to calculate the flux through this square only, and the flux through this whole cube is q by epsilon naught according to the Gauss law, so we can say flux through the one square, or flux through this square, what? The flux through this square will be q by 6 epsilon naught. Okay, this will be our answer. Now another point is question is asking that if a charge is at the vertex of the cube. Let's say charge is at the vertex of the cube. Let's say here is the charge placed, and the charge is, let's say, q. And then question asking what will be the total flux through this cube. So how we will calculate the total flux through this cube as well as flux through one surface of this cube. So to find out the flux through this whole cube, we will again draw an imaginary Gaussian surface which will keep this charge inside it. Here the total charge q is not inside inside this cubical structure, inside this cubical surface. This is basically on the corner, or we can also apply the concept of the chemistry, that is body centered, face centered, or edge centered concept. But we will use here another another concept, that as the charge is on the corner of the cube, so we can draw an imaginary surface, imaginary cubes that will put this charge inside of it. So how we will draw the imaginary surface? Imaginary surface will be like that. If this is the cube, we can just exceed another cube. We will just put another cube here. Let's say like this. Let's say like this, and another cube like this. So but still this charge is not inside the given cube. So we will again further increase another, we will place another cube here we will place another cube here, and again another cube at this point. At this point we will put. So we can see there are totally 4 cube at the bottom, but this 4 cube will also not keep this charge inside it, and we will put another 4 cube also above these cubes. Above this cube we will also put 4 cubes, so that this whole charge will be inside the cube. This whole charge will be inside the cube. We will put another 4 cube above the surface, and when we will put 4 cube above the surface, then this whole charge will be inside the cube, or we can say through this total cube through the larger cube, the total flux will be what? This total flux will be q by epsilon naught. And to cover this charge q inside a cubical surface, we will use total number of 8 cubes like that, a small cube. That means total 8 cube will be used to keep this charge inside it. So if total 8 number of cube will be used, and that through this whole 8 cube there will be q by epsilon naught flux, then through one cube will be what? Through one cube this total flux will be q by 8 epsilon naught. That means if we have only one cube, and the charge is at the corner of this cube, then the flux through this whole cube will be what? Q by 8 epsilon naught, because we will require total 8 number of cube like this to keep this charge inside it. Okay, so if there will be 8 charge, then the total flux through the whole this cube will be what? Q by epsilon naught. So the flux through a smaller cube, or the single cube, will be q by 8 epsilon naught. Now we want to calculate the flux through one surface of this small cube. Then what? Then the flux through three surfaces. This cube have total 6 number of surfaces, and the flux through the three surfaces which is touching this charge. There are three surfaces of this square: this surface, and another is this surface, and another part is this surface. These three surfaces touches this charge, and so the flux through these three surfaces will be 0, and the total flux, that is q by 8 epsilon naught of this cube, will passes only the remaining three surfaces. So if we want to calculate the flux through the surface or single surface of this cube, then the flux through single surface will be what? Q by 8 epsilon naught divided by 3, and this will be how much? This will be q by 24 epsilon naught. Remember that this flux is only through the surface which is not touching this charge, and the flux through the surface which is touching this charge will be 0. That means if you want to calculate flux through the surface which touches the charge will be 0. Now what will happen if this charge will be edge of the cube? Another point is, let's say this charge q is at the edge of this cube. We have this cube, and the charge is placed at the edge of this cube. This is the charge q, let's say. Then what will be the flux through this whole cube, and what will be the flux through single surface of this cube? Now to cover this charge q, we required how many number of the cube like this? So we will require total 4 number of flux, total 4 number of cube. One cube at this side, one cube will be required, or 2 more cube will be above this charge. So total number of 4 cube will be required. So total flux through that 4 cube will be what? That cube will be phi is equal to q by epsilon naught, and so flux through one cube is equal to q by 4 epsilon naught. That means flux through this single cube will be how much? Flux through this single cube will be q by 4 epsilon naught. Now we want to calculate the flux through single surface of this cube. So as the surfaces which are touching this charge will have no flux, and here when the charge is at the edge of the cube, then the flux that touches this charge will be this surface and this surface. These two surfaces will touch this charge, and so there will be no flux these two surfaces, no flux through these two surfaces, and so flux will be through only the remaining surfaces, and remaining surfaces are only 4, so we can say flux through the remaining surfaces phi s will be what? Q by 4 epsilon naught into 1 by 4, and this will be how much? This will be Q by 16 epsilon naught. This will be Q by 16 epsilon naught. Okay. Now, if you want to calculate the flux when charge will be at the center of the phase, that means if this charge Q is at the center of the phase, that means charge is let's say at the center here, at the center of the phase, then to cover this charge total two cubes will be required. Here just to keep another cube just above this cube, then this whole charge will be covered easily. So we can say by using one more cube, that means total two cubes will be required to cover this charge, and so we can say through these two cubes the total number of flux will be how much? Will be Q by epsilon naught, and so flux through one cube will be equal to how much? Q by 2 epsilon naught. But we want to calculate the flux through one surface of the cube, that means we know the flux through this single cube will be Q by 2 epsilon naught, and we want to calculate the flux through one surface of this cube. So surface that touching this charge will have no flux, and here is the only one surface is touching this charge Q, so there will be no flux through this surface, and remaining surface are total 5. So flux through one surface that not touches the charge, that not touches the charge will be Q by total 5 surfaces that not touches the charge, and so this flux is through that 5 surfaces, so we can say through one surface will be Q by 10 epsilon naught. We will divide this number by 5, we will get Q by 10 epsilon naught. This is the answer basically. So these are the basic concept of the Gauss law, and by using Gauss law we can also find out the electric field of a charge sheet. We can also find out the electric field of a line charge, as well as spherical shell, as well as not a spherical shell, as well as a solid sphere also, insulating a sphere also. We can easily find out the electric field. So in our next lecture we will discuss about the application of the Gauss law in different bodies. Okay, and here I'm going to stop my lecture. Thank you so much.